Hello everyone, myself Sabina Devi, Assistant Professor, Department of Physics. In this video, I am going to explain about the case study on Young's modulus by uniform bending. Okay, so exploring the fundamental material property that underpins the structural integrity. So in this video, I am going to explain about the case study of Young's modulus by uniform bending. So here the case is, so why Young's modulus matters? So what is meant by Young's modulus? So in previous video, I explained about what is elasticity. So what is meant by Young's modulus and other factors, right? So what are the different definitions, right? So Young's modulus is nothing but longitudinal stress to the longitudinal strain. So in Young's modulus, we have two different types. One is uniform bending, another one is non-uniform bending. So uniform bending is nothing but the force applied to the both the end of the material, right? So in your non-uniform bending, so the load applied to the only in middle portion and only one edge. Okay, that is called as non-uniform bending. So in this case, so I am going to explain about the case study on Young's modulus uniform bending, right? So why Young's modulus matters? So here the question. So first one is fundamental stiffness. So the ratio of stress to the strain, right? So first one is the fundamental stiffness. So due to that fundamental stiffness, we need Young's modulus, right? So next one is engineering design. So predicting deformation under load. So we predict by using the Young's modulus, we will predict the deformation under the load. So while applying load to the body, so how it will deform, how much amount it will deform. So the engineering design will be analyzed, predicted by using Young's modulus. So reliable measurement, the practical for beams and cantilevers. So these are all the three factors to why Young's modulus matters, right? So next one is theoretical foundation and beam bending. So we know that the formula, reduction formula of Young's modulus of uniform bending. So the formula will be Young's modulus S is equivalent to 4F L cube by BD cube E. So this is the formula for Young's modulus uniform bending. It will be explained in previous video. So relates for F is the force and L is the length and B is the breadth of the material and D is the thickness of the material. So here E is the elastic modulus, right? So this is the deflection formula. So using this formula, we will predict the curvature of the body. So uniform bending allows precise calculation of Young's modulus from measured deflections, right? So we will get accurate measurement, controlled geometry, and precise load application. We will predict a predictable curvature. Using this formula, we will predict this curvature of the body, right? So experimental setup, the cantilever beam. So cantilever is nothing but, one end of the scale is connected to the wall or fixed, and another end is free end. So in the free end, we have to apply the load in the free end, right? So here the key element of beam fixed at one end. So load is applied to the free end. The deflection measured precisely. The laser, digital imaging will be measured precisely, right? So for example, integrated bamboo rods tested by deflection method to find the elastic modulus. So we are using elastic modulus. So we have to find the find the elastic modulus of the material. So we have to use Young's modulus and cantilever, right? So micro bending case study. So nano twinned copper. Okay. So here. So this is the micro bending case study. So key findings for the nano twinned copper. So that are the Young's modulus. It has the value 78.7, 11 GPa, and bulk copper. So it has 117 GPa. Plus or minus 11 GPa, so Young's modulus of nano twinned copper is 78.7 plus or minus 11 GPa, right? So for bulk modulus, it has 117 GPa. So nano twinned twins increase the flow stress and blocking the dislocation movement and applications of micro nanoscale with advanced instrumentation. So these are all the case study of micro bending case study of nano twinned copper, right? So advanced analysis of video-based optimization. So it has full bending profile, extraction profiles from video recordings, and it will has advanced analysis. It will useful in the advanced analysis also. That is video-based optimization, right? So full bending profile and optimization algorithms and complex materials, right? So in optimization algorithm, it will improve the accuracy of Young's modulus. So the complex material, the characterize stiff and brittle materials in the single test. Okay, so this is only advanced analysis. So accuracy factors in bending test span to the thickness ratio. So the critical for reliable modulus, right? So I by h is greater than 7. It is the span to the thickness ratio. So the cross-sectional uniformity, the essential for precise result. So it will get maybe using so these are like accuracy factors. So cross-sectional uniformity, then load measurement. So accurate and consistent application. The load measurement also very useful factor. So optical distortion account for noise in the data analysis. These are all the accuracy factors in the bending test. Okay. So practical applications. So practical applications and insights. So bending test reveals mechanical behavior across the diverse materials like bamboo beams to silicon nanowires and copper interconnects. And so these are all the bending tests which reveal the mechanical behavior of across the any materials, right? So design stronger and lighter components and material selection and quality control, advanced engineering and electronics, biomaterials. These are all the practical applications and insights of Young's modulus. So visualizing the impact from elastic modulus, understanding the material limits. So these are all the. So let us conclude that. We conclude that a powerful tool. So it is the powerful tool. So this is comprehensive. So and scalable and innovative and next steps. Okay. So comprehensive theory, precise experiment and modern analysis. This is really comprehensive conclusion. And scalable is macro beams to micro or nano structures. So innovative, it has advanced material science in the engineering. So next steps are to integrate the bending test with digital analysis for next gen material characterization. So this is all the case study of. So this is the case study of Young's modulus and bending. Thank you all.